NEC Table 310.15 B16 provides guidance on the current carrying capacity of aluminum busbar. For a 4" by 1/2" aluminum busbar, the table indicates a current carrying capacity of 130 amps. This value is predicated on specific conditions. Firstly, the table assumes a 75 degrees Celsius temperature rise. Secondly, the busbar is installed in free air. Thirdly, there must be at least 12 inches of clearance from walls and other enclosures. It is crucial to understand that these conditions significantly impact the busbar's ability to dissipate heat and maintain a safe operating temperature. If the busbar is enclosed or installed in a confined space, the current carrying capacity may need to be reduced. This is because the enclosure restricts airflow, impeding heat dissipation and potentially causing the busbar to overheat. Overheating can lead to insulation damage, reduced conductor lifespan, and even fire hazards. Conversely, the current carrying capacity can be increased if the busbar is cooled by forced air or other means. Forced air cooling enhances heat dissipation, allowing the busbar to carry more current without exceeding its temperature rating. However, any modification to the cooling system must be carefully engineered and implemented to ensure reliable and consistent performance. While NEC Table 310.15 B16 provides a general guideline, it is always best to consult with the manufacturer of the busbar for specific recommendations. Manufacturers often have detailed specifications and testing data for their products, which can provide more accurate current carrying capacity ratings based on the specific application and installation environment. Factors such as the alloy of the aluminum, the surface finish of the busbar, and the type of connections used can all affect its thermal performance and current carrying capacity. When selecting a busbar for a particular application, it is important to consider the following. Firstly, the continuous current demand of the load being served. Secondly, the ambient temperature in the installation environment. Thirdly, any potential for future load growth. Fourthly, the dirting factor specified in the NEC for conductor ampacity. Fifthly, the voltage drop limitations for the circuit. Sixthly, the short circuit current rating of the busbar. Seventhly, the mechanical strength requirements of the busbar. Eighthly, the environmental conditions to which the busbar will be exposed. By carefully considering these factors, engineers and electricians can ensure that the selected busbar is appropriately sized and installed to provide safe and reliable electrical service. It is also important to periodically inspect busbars for signs of corrosion, overheating, or mechanical damage. Regular maintenance can help to identify and address potential problems before they lead to equipment failure or safety hazards. When performing maintenance on busbars, always de-energize the circuit and follow proper lockout-tagout procedures. Use appropriate personal protective equipment, such as gloves and eye protection. Clean the busbar with a non-conductive cleaner to remove any dirt or debris. Inspect connections for tightness and corrosion. Replace any damaged or corroded hardware. Properly torque all connections to the manufacturer's specifications. Document all maintenance activities. The NEC provides detailed requirements for the installation and maintenance of busbars in Article 366. This article covers topics such as allowable ampacities, overcurrent protection, grounding, and clearances. It is essential to be familiar with these requirements to ensure that busbars are installed and maintained in accordance with the code. In addition to the NEC, other industry standards, such as those published by the Institute of Electrical and Electronics Engineers, provide guidance on the design and testing of busbar systems. These standards cover topics such as thermal modeling, short-circuit testing, and vibration analysis. By following these standards, engineers can ensure that busbar systems are designed to meet the performance and reliability requirements of the application. Aluminum busbars are widely used in electrical power distribution systems due to their high conductivity, lightweight, and relatively low cost. They are commonly found in switchgear, panel boards, and other electrical equipment. Aluminum is a good conductor of electricity, but it is not as conductive as copper. Therefore, aluminum busbars must be larger than copper busbars to carry the same amount of current. However, aluminum is much lighter than copper, which can make it easier to install and support. Aluminum is also less expensive than copper, which can make it a more economical choice for large-scale power distribution systems. When using aluminum busbars, it is important to use connectors and hardware that are specifically designed for use with aluminum. Aluminum is more prone to corrosion than copper, so it is important to use connectors and hardware that will prevent corrosion. It is also important to use the proper torque when tightening connections to aluminum busbars. Over-tightening can damage the busbar, while under-tightening can lead to loose connections and overheating. In addition to aluminum, busbars can also be made of copper or other conductive materials. Copper busbars are more conductive than aluminum busbars, but they are also heavier and more expensive. Other materials, such as steel or stainless steel, may be used for busbar supports and enclosures. The choice of material will depend on the specific application and the environmental conditions to which the busbar will be exposed. The shape of a busbar can also affect its current carrying capacity. Flat busbars, such as the 4" by 1/2" busbar described in the NEC Table, are commonly used in switchgear and panel boards. Round busbars are often used in high current applications where space is limited. Other shapes, such as square or rectangular busbars, may also be used depending on the specific application. The surface finish of a busbar can also affect its thermal performance. A smooth, clean surface will dissipate heat more effectively than a rough, dirty surface. Therefore, it is important to keep busbars clean and free of debris. The NEC requires that busbars be protected from physical damage. This can be achieved by enclosing the busbar in a cabinet or enclosure. The enclosure should be properly grounded to prevent electrical shock hazards. The NEC also requires that busbars be properly supported to prevent sagging or bending. The support should be spaced according to the manufacturer's recommendations. When installing busbars, it is important to follow all applicable codes and standards. This will ensure that the busbar system is safe and reliable. It is also important to consult with a qualified electrical engineer to ensure that the busbar system is properly designed for the specific application. In summary, determining the current carrying capacity of an aluminum busbar requires careful consideration of several factors, including firstly the busbar size and material, secondly the installation environment, thirdly the applicable codes and standards, fourthly the manufacturer's recommendations. By taking these factors into account, engineers and electricians can ensure that busbar systems are safely and reliably designed and properly installed for the intended application. Always prioritize safety and consult with qualified professionals when working with electrical power distribution systems. The information provided in NEC Table 310.15 B16 and by busbar manufacturers serves as a crucial guide for safe and effective electrical installations. Understanding and applying these guidelines are essential for preventing electrical hazards and ensuring the long-term reliability of electrical systems. Remember to stay updated on the latest revisions to the NEC and other relevant standards. Continuous learning and professional development are key to staying current with best practices in the electrical industry. This commitment to excellence will contribute to safer and more efficient electrical installations for everyone. Moreover, consider the impact of harmonics on the current carrying capacity of busbars. Harmonics are distortions in the alternating current waveform that can cause increased heating in electrical equipment, including busbars. If the electrical system is known to have significant harmonic content, it may be necessary to direct the busbar's current carrying capacity to account for the additional heating. Harmonic filters can be used to reduce the level of harmonics in the system and improve the overall efficiency and reliability of the electrical system. Furthermore, proper grounding of busbar systems is crucial for safety and performance. Grounding provides a path for fault current to flow back to the source, which helps to trip over current protection devices and prevent electrical shock hazards. The NEC provides detailed requirements for grounding electrical systems, including busbar systems. It is important to follow these requirements carefully to ensure that the system is properly grounded. Finally, consider the long-term maintenance of the busbar system. Regular inspections and maintenance can help to identify and address potential problems before they lead to equipment failure or safety hazards. Maintenance activities may include cleaning the bus bars, tightening connections, and inspecting for signs of corrosion or damage. A well-maintained Busbar system will provide many years of reliable service.